Thank you for taking the time to watch this video by Transoft Solutions during Mobility Week. This is part one of a three-part series. Your presenter today is myself, Willem Bouwer. I'm the Business Development Manager, Civil and Transportation for Transoft Solutions EMEA. The three-part series for this Mobility Week consists of the following: safety concerns at intersections. That is the video that we will look at today. Then the next one will be success stories, new urban developments and complete streets, and this will follow shortly. And then we will explore future cities with less modal conflicts and a safer shared space for micromobility and walking. So to kick off today's presentation and demo that I will be doing, we'll be looking at the safety concerns at intersections and roads where there's multiple modes of transport and they share the same space. And then we'll look at proactive road safety analysis using video analytics, swept path analysis of the urban space improvements, and we'll test that. And there'll be a quick introduction to complete streets and new urban design concepts, which is a follow-up to our next video in this series. Safety concerns at intersections and along the road normally deals with conflicts, incidents and accidents, and the magnitude and severity thereof. For this slide, I'm just going to show a couple of conflicts, and you can clearly see them at a traditional four-legged intersection and at a typical roundabout, and it's between multiple modes for crossing, merging and diverging movements. And you can also see it for a protected roundabout where the bicycle conflicts has been reduced as compared to the shared path and roadway bicycle conflicts in the traditional type of roundabout. So safety concerns can be the following, amongst others: speed, conflicts like I've shown you here, traffic volumes, travel time and delays, the compliance with traffic control devices, sight distances and visibility. We'll get into sight distance and visibility examples later. Incidents and accidents, road infrastructure, obstacles, driver, cyclist and pedestrian behavior. And we've got a good example of this later. And then also vulnerable road user safety, policies, and there are many more. The ultimate measure of the success of a road safety policy or intervention is the effect that it has on crash reduction. In particular, the reduction in fatal and serious injuries. And I'll show you examples of this going forward. In the next section, I'm going to demonstrate some technology that we're going to use today. The first is Traffic Safe, which is our advanced AI technology, and then AutoTurn, which is used for doing accurate swept path analysis, and it can be for multiple vehicles. So in this section, we're going to look at first Traffic Safe. It is computer vision that's used with artificial intelligence and machine language. So in the first section, we detect the road users and we put them in categories, and this is done automatically. We use computer vision to detect and identify each moving object in the video frame. Here you can see each video, pedestrian, and all the rest are categorized and they're actually tagged. Secondly, we track each road users frame by frame over time to get the complete information for our analysis. This allows us to capture their speeds, their trajectories, and we use this as the basis for the analysis of their interactions with each other. And then finally, in the analysis phase, we run our road safety analysis. We detect near-miss conflicts. And with this information, we are able to then generate safety metrics and provide meaningful analytics to use for the overall safety evaluation of the current system. In the next slide, I'm going to show you an example of how we use this technology. In this slide, we're going to look at a video that was analyzed by Traffic Safe. It shows a before and after study. We firstly identify near misses. Secondly, we determine the root cause of that. It is done by identifying high-speed areas, highly problematic movements and turns, and we also shed some light on driver and cyclist behavior. The after study shows how the near-miss incidents were reduced by intersection improvements, and Traffic Safe can measure the benefit of these interventions. And I'll show that to you in one of the next slides. So let's quickly look at this video. And before improvements, you can see the cyclists coming along. You can see the side distance there with the arrow. And you've got this area of interaction that's shown with the yellow. And then after improvements, it's a protected intersection. With the arrows, you can clearly see side distances are longer for the driver and also for the cyclist, so that they can make decisions early, so that they can prevent incidents and accidents from happening. In this slide, I'm going to show you before and after mitigating measures. On the left, you have the intersection as it was. On the right, in the yellow, you see corner islands that were introduced. The corner islands, they extend the protected bike lane separation as far as possible into the intersection. The corner radius, they were also reduced, which resulted in reduced vehicle speeds when they turn. On the northeast and southwest legs of the intersection, the bicycle lanes were set back. The setback creates a waiting area for vehicles that turn, and they yield for bicycles. This is this movement here. The sight distance for both the cyclists and the drivers are improved, and it leads to a safer movement where there's a longer sight distance and thus more time to react, overall resulting in a safer movement for both users of the road infrastructure. And in this slide, I'm showing you our sweat path analysis tool, AutoTurn, where we do sweat path analysis. And this is where the before study, you see high speeds in this area shown by the orange hashed area. This is a speed analysis that's done on top of a sweat path analysis in AutoTurn. So the orange is the highest speed, and then we'll look at what was the impact of the improvement. So in this area, you can see more green, and the green indicate lower speeds. So the result is, because it's a protected intersection with longer paths for the bicycles, in this case here, you see a reduction in speed, and for the vehicles where the turns are tighter, you see a speed reduction, and this is accomplished by the setback crossing, and greater visibility is achieved. Here we have the drawings in AutoTurn, and this is an aerial photograph of the area, and I've done a sweat path analysis on it, and you can see AutoTurn has got an extensive library of bicycles and vehicles, and this is where we select our vehicles from, and there's multiple libraries in here, and you can see various vehicles that we can test. So I selected, in this case, a standard bicycle and then a standard design vehicle. I generated a sweat path, and it's very easy to do. So I clicked by using 2D ArcPath, and if I do it for a bicycle here, you could see I could quickly just do that, and you can change the speed also for a bicycle. So that was done, and then I did a speed analysis. So this was the bicycle movement, and this is the vehicle movement as it turns. And then the improved version of this is this, where you can clearly see that speeds are reduced, in other words, more green here on the turn, and the sight distance is improved. Traffic Safe can help you to visualize the impact of the mitigating measures by quantifying and qualifying the near-miss conflicts observed after a junction reconstruction project. This heat map on the left shows this for the after study. The conflicts included in the yellow circle area are fewer than in the before study. The heat map on the right represents the speed. There was a speed reduction due to the mitigating measures. I specifically referred to the darker color in the yellow circle that represents an approximate speed of about 15 kilometers per hour or less for the turning vehicle movements. In Traffic Safe, you can compare multiple scenarios, allowing you to evaluate before and after studies in detail. This is an introduction to our next video where we will explore complete streets, multimodal streets, as well as design concepts like shared spaces and the superblocks model as implemented in Barcelona and other cities. We will look at the success stories and get more insight on how to analyze the before and after studies. Thank you for joining me for part 1 of 3, and I hope to see you shortly in part 2. Enjoy your day.